Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience. Hi everyone, today we have with us Thomas Swift, who is a lecturer in polymer chemistry at the University of Bradford. Hi Thomas, how are you doing?
I'm really well considering the circumstances.
Okay, I hope you're safe and healthy.
Yes.
Okay, wonderful. Let's start. Do you explain your research in super simple words to us, please?
Okay, so I'm a polymer chemist. I say polymer, a lot of people are familiar with the term plastics, but there's so much more to big molecules than plastics and these big commodity products we're used to. So I study these functional materials, polymeric materials. So a polymer just means a really big molecule. I don't particularly have a distinction whether it's biological, so a lot of liposaccharides and proteins, enzymes, DNA, that's a polymer, and synthetic materials, which is all the stuff where we sort of coat our everyday world in. But I'm really interested in how we can functionalize it and make it useful for specific applications. So these might be things sort of things that bind and remove things. So if you want to purify water, you'd add something that binds a flocculate and take all the dirt out of solution. That's a common usage. Or a diagnostic tool, I work with a lot of people who use these as sensors that can detect explosive TNT compounds or other polymers if you've got pollutions in there, or bacteria. So infection of diseases is a really topical thing right now. And then the third functional use would be an adhesive or a property modifier. So if you've got a material which is a barrier, so if you think a wound dressing, but you put a functional polymer in that, we can tune how much air passes through it, which will make the bandage much more comfortable to wear. We think of plastics as these big bulk materials, but polymer chemistries really brought the world some unique and brilliant properties, which we've used over the last 50 years, or 100 years really, and we've made use of, but we've never really appreciated why they're so special. And this could be why it's a big global pollution problem right now. And I'm not alone in looking around the other polymer chemistry community. And there's been a moment over the last year where we've looked at each other and gone, are we the bad guys? I really don't think we are. But we are capable of doing so much more to be better than we have been. But that's because this is, the technology is only 100 years old, and that feels old, but in the grand scheme of things, we're running before we can walk. So I've got a bit of chemistry, a bit of physics, a bit of biology, but really it's about how science and material science interacts with the world around us.
Okay. That's really interesting, and I want to tell you guys that you're not the bad guys. It's
Thank you.
No, but that sounds really interesting and wonderful, and we hope to understand it even more in detail in the week that you curate the Real Scientist Nano account. Which brings me to the next question, which is, what can the followers expect in the week that you will curate the account?
Okay, so quite a variety of different things, because plastics and polymers do permeate so much of everyday life. For me, the opening thing is everyone thinks they know what a plastic is. You go around, you pick something, and you say, "Oh, it's a plastic." For most people, when you say it's a plastic, that kind of closes the conversation down. But for me, that opens 1,000 new questions in my head. You say it's a plastic, I go, okay, well, what's the materials architecture? What's the chemical structure? What specific functionality do it have? And these are questions we're still as scientists trying to get our head around. It's an important topic, and using them as bulk commodities is doing really ecological harm. And this is not because the materials themselves are at fault. It's because they're overused in scenarios that we were never expected to use them to. But I think that to just throw away all of the scientific advancements over the last 100 years would be a waste. If we can start using these in more like less single-use ways and more functional ways. I want to talk about the principal colloid science that drives functionality of polymer materials, looking at materials characterization techniques. So the trouble is, the interesting stuff is all happening on the nanometer or definitely sub-micron scale. And it's very, very difficult to actually look at something that small and see what's happening, particularly when then what's happening is situation and environmental dependent. So materials characterization techniques are being developed all the time, and there's some really bizarre and interesting stuff out there that we can pull up on. A general criticism I see of the polymer chemistry community or polymer scientists is, do we really understand statistics, and is it a problem? There's a fascinating paper from a French author that came out about 2 years ago about polymer dispersity. I'd like to pull up and see if that can spark a conversation. The interaction between polymers and nanomaterials, that's quite an exciting piece of work. I really can't do the topic without talking about public policy decisions on recyclable and degradable materials. I mean, you just say, okay, it's fine, recycle your plastics or make them degradable. Both of these solutions sound great in principle, but there's massive issues that need pulling out. We've all heard of microplastics, but as ever, the situation is more complex than people think. And then finally, probably on the last day, seeing as it's topical with the coronavirus, our group, I've been working with Professor Stephen Rimmer, who's also at the University of Bradford, and for over a decade now, he's been working on polymers for infection diagnostics. Now, our work's really bacterial based, but whether it's virus or bacteria, there's some really interesting work on polymers for synthetic materials that could be developed to detect infections. And I'd like just to show both what we're doing and other people in the community, which might show, okay, this isn't technology that we've got now, but things that we can do over the next 5 to 10 years that could help us avoid situations like the coronavirus pandemic we're in right now. Technology is hopefully going to be a way out of this in the future.
Yeah, that makes sense. Yeah, this is amazing. It's gonna be interesting. I'm just gonna say it and keep it short. But yeah, this is gonna be amazing as you're gonna cover a lot. So it will be a week full of information, and can't wait for you to curate the Real Scientist Nano Twitter account. Thank you very much, Thomas, for speaking with us.
Oh no, thank you very much. I'm looking forward to it.
Thank you for listening. To know more about us, please visit our website realscientistsnano.org and follow us on Twitter at realsci_nano.